is the case with all the research passes. And I mean you should, of course with all respect to your name and knowledge, look to the matter from a different angle.
There is no different angle. Scientific methodologies will determine all the options and paths of a scientific research. We are scientists who observe, analyze, and discover and give answers, solutions, and this is the only way to do it.
I'm not arguing this at all. It's just that I also believe luck plays a major role in our domain. And you don't believe in luck?
No, I do believe in it, but not in making and discovering major scientific facts and inventions with it.
Yes, this is my point. You don't believe in accidents leading to discoveries, but luck exists. And science is also having a part of luck. And I'm telling you that throughout our daily life, some stuff happen by luck that changes our path forever.
You said it. This happened in life, but not in labs.
Well, if you don't see this as a professor or scientist, how can you then explain the major breakthroughs that happen every day in our labs through our rigid observations and experiments? I mean, those discoveries that happen in labs, it actually turn into great discoveries that we all benefit from. So my point is, scientists do benefit from the upcomings, whether they are good or bad.
Okay, those upcomings are results of calculations and methodologies done in the labs. And please, don't be so chaotic in your way of thinking. Try to put the methodology and follow it. And please, again, how old are you? And what's your name? And in which field did you get your PhD? Excuse me, you're wasting my time, and I have a lecture to prepare.
Okay, I'll tell you this in other point. I'll tell you in other words. Let's take Newton, for example, when he discovered the law of gravity. For example, do you think that Newton was sitting behind, the tree and holding his huge book or his microscope waiting for the apple to fall on him? Or did he even put a hypothesis for it before it happened? No, instead when it happened, it caught him and he started to research and find until we reached the discovery, which is the law of gravity. That's what I'm talking to you about. That is science. And we do not live in our labs isolated from the real world. We live outside, we work, we discover new things.
I'm still convinced we need to have a methodology and in scientific research. And please, Newton was already grabbing info and observing all of the surroundings when the apple fell off.
Anyway, in all cases, I was just opening this conversation because I'm working on this research and I thought I can have your assistance.
I told you I have no time.
Just give it a try. Maybe it will turn out that I'm wrong in the end. It's just that I'm proposing some questions that I'm really seeking for their answers.
Okay, tell me your questions.
Okay. Do we believe in luck? And does luck play a major role in our life or in science? And do we know what serendipity refers to? Something else. How comes that scientists start working on something and end up working on a totally different thing?
Okay, and did you get any answer for all those questions?
Well, I don't know, but as young scientists, I would really love to seek finding the answers to those questions. So I do believe that sometimes there is no one answer to our questions. Sometimes you have all those possibilities around, and it belongs to us to decide which path to take.
Okay, I will give it a shot, and I will try to help you. But please, you will have to prove me your point, okay?
Okay, fine. Then I'll prove to you my point with an example. Let's go back in history and learn about some discoveries that happened before. See how they came up. See how they really reached the way they are today. Let's go back in history to the time of the World War II.
So, we won in Hiroshima and Nagasaki. We made the greatest weapons in history, and after all, we invented the radar, which helped a lot to detect the enemy's planes and deal with them.
Sir, yes, sir. It was a great invention, and it was amazing how we can send a wave and receive it again to know all the information about the enemy's aeroplanes.
Yeah, tell me about it. It's amazing how this black box can send electromagnetic waves with a specific frequency and receive them again after they reflect from the planes with another frequency. And with simple mathematical equation, we can determine the speed and the range of the plane.
Indeed, sir.
Yeah.
But I think there's a problem now, because the radar waves can be focused in a specific direction because of the long wavelengths.
Yeah, what I was about to say. We have a problem. as you can see here, the electromagnetic spectrum starts with radio waves, which is the radar wave, with very long wavelength, and ends with gamma ray, with very short wavelengths, which is also energetic and harmful. And as the wavelengths decrease, as we can focus the waves better, and then we solve your problem.
So maybe we need to work with the magnetron now. So if we adjust it in the right way, because the magnetron is a device which generates the electromagnetic waves. So if we adjust it well, maybe we can direct it in a
Actually,
very
no.
good... Okay,
I have another item.
So tell me, sir.
I think we should reduce the wavelength without reaching high energetic level.
Okay.
And you can do that by working on the magnetron.
I was just saying.
Are you saying something?
How brilliant are you, sir?
Yeah.
So what you want me exactly to do?
I want you to adjust the magnetron and reduce the wavelength until you reach the microwaves level. And then you will focus the waves in a cone shape on the planet.
Okay.
Work on that now.
Oh yes, sir.
Yeah.
I will just adjust the magnetron now, and I will read
Yeah,
and save
update
everything.
me, please.
Okay, but I'm sorry, sir.
Yeah?
I'm just starving. I have been working from about 8 hours.
What's wrong with you, soldier?
I'm sorry, sir. I'm starving now.
Okay, you touched my heart.
Thank
And
you,
I'm
sir.
always prepared for such
Thank you,
things.
sir. You're so
I
kind.
have, wait a second, a whole bar of candy for both of us. You know, it's army money.
Excuse me, sir. It even melted.
Oh yeah, a good question.
So what happened?
I think what happened here, that because of the microwaves that you just generated from the magnetron, its heating effect affected the candy bar and melted it. But the question here, the heating effect can affect only the water molecules.
No, sir. For any kind of food, we have a water molecule percentage. So when we adjust the microwave as a magnetron to a microwave, the microwave affected directly the water molecules inside the candy bar. And as a result, the candy bar had been melted.
Yeah, whatever you said.
Thank you, sir.
You know what? If you're not working on that rather thing, and 3 years from now, I would say we can cook our food using radar books. Yeah, radar books say, I'm crazy.
No, sir. Who knows?
Okay, so that's how was microwave ovens invented? Huh?
Well, believe it or not, it is. It was invented by, just like we saw, when that American engineer who was trying to work on something like improving the radar signals, and he got a totally different thing.
Okay, I believe it happened, but don't take a 1% chance that is common and happening in everyday life. Okay, and you already mentioned that was an accident.
Yes, it was indeed an accident, but not just an accident, a happy accident.
Okay, same, whatever.
No,
same point.
not the same. I'm talking about the real terminology here. It is the term happy accidents, or as some others might call it, serendipity. That means that is a useful accident, which is the accident when you find something useful or good where you were not specifically searching for it.
Okay, let's say I believe you. If that, what was it called?
Happy accident, serendipity?
Serendipity, yes. If that serendipity really exists in scientific research, as you are saying, and it's very common, so it would need a very clever individual, which is here the scientist, to be very clever, to grasp all these facts in front of him that he would never expect it at first, and have available conclusions that he wouldn't expect. And please, trust me, this thing is not very common between scientists.
With all my respect, but I think you're wrong. I do believe instead that curiosity and observation are among the basic skills that real scientists possess. That is like, in other words, a scientist have a very well-prepared mind to accept everything that happens. You don't seem convinced.
No, I'm not convinced, and please, I'm still considered that this is not very common.
Well, if you're not convinced, then I'll have to give you another example. Let's go back again in history and learn about another discovery that I bet you don't know about. It happened as well in 1903. Let's go back to our scientists in their labs.
So, listen to me, when you are working on the lab, you have to be so careful. Some stuff here, we don't have them in the stock.
Okay, I told you. Don't worry, my friend. Have you heard about the accident that happened yesterday?
Yeah, actually I heard about it, but I cannot figure out why they died. Is it because of the hard car collision?
No, I don't think so. It's written here that The people died due to the strong car crash. So when the car crashed, the windshield itself broken into very small glasses, and the passenger died because of the strong, quick car shattering or glass shattering. It was terrible.
Yeah, I'm sorry for them actually, but you know what? Maybe someday someone will figure a solution for this glass shattering problem. Who
Yeah, I
knows?
know too. I'm so sorry, and I can't understand why the car industry don't have a solution for this car shattering until now.
Actually, I don't know. Please, can you help me here? I need the cellulose nitrate flask. You will find it on the table in front of you.
Okay.
It's not working
okay,
here.
Okay, give me a second, please. I can see it. It's not here.
I'm sure you will find it on the table in front of you. Please search for it. I left it long
This
time
one is
ago.
not the serious nitrate. I know the serious nitrate. It's not here. Oh my God!
What happened?
I broke a flask, but don't worry, don't
Oh,
worry.
wait,
Don't
wait,
worry,
wait,
it's
let me
empty.
see. No,
It's
please, let
empty.
me see.
It's empty.
No, it's not. This is the cellulose nitrate flask. Oh my God. Oh, I see. This is the cellulose nitrate liquid, but it evaporated long time ago because I left it unclosed.
I told you, I
Yeah.
can't see it. It's not here, but by the way, I will clean this mess for
Yeah,
you.
please
so
clean,
Don't,
please
don't,
clean.
don't worry, don't worry. I will clean.
Wait a second.
Okay. What?
Can you see that?
What happened?
The cellulose nitrate flask broke down without making any mess, and is still holding itself in one piece. This is amazing.
Very, very good observation, my friend. Maybe what happened when the cellulose nitrate evaporated, it created a very thin layer inside the flask. And this layer acts as a very strong adhesive material to the flask. So when it falls down, it didn't break.
Oh my God.
Oh my God.
Oh my
you
God.
You think what I'm thinking of?
Yeah.
Yeah.
We need a new solution.
No. I'm saying that if the cellulose nitrate acts as adhesive material,
Yeah.
so maybe it can be used for the car accident. So it's very thin and it's very transparent. It's very
Yeah.
strong. So we can use it when the car crash happened. We
Yeah.
can use it in the car windshield.
I like that. And you know what? We can use a thin layer of cellulose nitrate between two glass sheets and compress them. So we can have 3 layers glass sheet, which will be transparent, as you said, and which also will resist the hard car collision. And then we can save the passengers during car accidents.
I like your idea. And that's why maybe we can call it Triple X safety glass.
I like that.
Thank you.
But please, take care.
I told you, I'm sorry.
Work on it. You have to take care.
See, and that was how the safety glass was invented. And it was invented actually by a scientist who was called Edward Benedictus. Just like we saw, the same incident happened. Oh, and another important piece of information is that that safety glass was then used in the World.
That was a good example.
So, meaning you do agree?
Kind of.
Come on, admit it. You do agree that scientists and luck can turn into the great discoveries ever.
Okay, I do agree. Yes, I agree. And to prove to you, I'm going personally tell you a story about that.
Oh, you
yes.
will? Okay.
While you were telling me your stories, actually I did some deep researches and I found some amazing facts and discoveries done by pure luck. Did you know, for example, that the Big Bang Theory was discovered by pure luck?
Oh, honestly, I didn't know this.
Yeah. I will tell you another story. Do you know the mauve color? We all know the mauve color. Actually, this was discovered by pure luck also when a chemist was in his lab doing his experiments and he failed in all his original experiments. But actually, instead, he got a very light purple color that he called mauve. And you all know that the mauve color changed the world of fashion till now.
So, accidental discoveries have been a topic of discussion long time ago. And actually, Kevin Duber and Jonathan Fugelsang said that somewhere between 33 and 50% of all scientific discoveries are unexpected. And actually, until now, scientists themselves are not able to detail exactly what role does luck play.
And exactly that, even though not the prepared experiment only is only the way to have a very good inventions or discovery, but having a very good prepared mind and have a clever and intuitive scientist will lead you to the important discoveries. And that's what we call serendipity, or the happy accidents. And that is the fundamental for important intellectual leap of understanding for every scientist.
So, scientists always say that the process of discovering something new starts when a researcher finds a bug in his experiment. These unexpected results leads him to try to fix what he thinks that it's an error to his first methodology. And he always decides that this error is too systematic, that it can't be a coincidence that can lead him to something new that he didn't even expect it at all at first. And in that way, luck will never happen.
In other words, and to conclude to what was just said, the human brain can be prepared in two different ways. A way of obstructing serendipity, happy accident, which is if for example, the person is adhering too much to his expectations, or the other way around, which is what we believe in. We simply believe that we need to consider the beauty of errors or the deviation from plans because simply, sometimes, they open other gates and options. But I'd really like to conclude my point with a very important terminology that a famous scientist wrote. He used to describe science by saying it is anti-fragile, meaning like while other ways of investigation tend to be very fragile in the face of human error and randomness, science, on the other hand, pays attention to such randomness and benefits from it. That's why it is anti-fragile. And we do believe that the more anti-fragile science would be by us scientists, the more it can flourish the whole world. Thank you.
Thank you.
Thank you.